Java 8. See, JDK 1.8. You can also call Java 8. You can also call Java SE 8. All are same. Okay. These all are same. JDK 1.8 or Java 8 or Java SE 8 features. These all are same. JDK 1.8 or Java 8 or Java SE 8. First one, new date and time API. New date and time API. Second one, default methods in interface. Static methods in interface. Functional interfaces. At functional interface annotation. Lambda expressions. Lambda expressions. Predefined functional interfaces. Method references. Constructor references. Stream API. Optional class. Total 11 features. JDK 1.8, Java 8 or Java SE 8. JDK 1.8 or Java 8 or Java SE 8 features. First one, new date and time API. Second one, default methods in interface. Third one, static methods in interface. Fourth one, functional interfaces. Fifth one, at functional interface annotation. Sixth one, lambda expressions. Seventh one, predefined functional interfaces. Eighth one, method references. Ninth one, constructor references. 10th one, stream API. 11th one, optional class. So total new features, 11 features are there in 1.8. JDK 1.8 you can call, Java 8 you can call, Java SE 8 also you can call. All are same. All are same. I'll explain. First one, new date and time API. New date and time API. First one, new date and time API. You already studied for getting system date. For getting system date, which class we used? Date class. For getting system time also, date class. Date class in which package? Recently you studied java.util, collections, legacy collection. Recently you studied legacy collection. But that collection, that class, they are planning to remove from Java library. These new classes came. Java.time package came. Java.time package. In this package, local date class, local time class, local date time class. 3 classes introduced in this package. Note on. New date and time API, Java.time package introduced in that 3 classes, local date class, local time class, local date time class. If you want only date, local date. If you want only time, local time. If you want both date and time. Okay. Is it over? Now, for getting date and time, we use date class only. For getting time also, we use date class. For date also date class. Date and time purpose, only one class was there previously. But as compared to that one, these classes are powerful. That is the reason that is they are planning to remove from Java library. That is, while using that class, you are getting message deprecated. So what they are saying is don't use that class in real-time projects. That is they are saying, because in future they are planning to remove from Java library. As compared to that one, this is a powerful class. How it is powerful? Suppose what is today's date? 19th July 2023. Okay. Now, after 1 month, 19th August 2023. After 1 year, 19th July 2024. After 10 weeks, no answer. After 100 days, no answer. We have to calculate. But here methods are there. It will give that answer. So after 100 days or before 100 days or after 100 hours, before 100 hours, like that also possible. There are so many methods in these classes. Forward, backward, both sides you can move cursor. Today's date to forward direction, backward direction, all possible. Hours, minutes, seconds, nanoseconds also calculated. That type classes they given. That's what, after getting these classes, that class outdated. They are planning to remove from Java library. Okay. How to use, you observe. Just one class I'll explain. Few methods I'll explain because so many methods will be there. Any class you take in the Java, hundreds of methods will be there. See, Java P, Java.time.local date. You observe? Java.time.local date. How many methods you observe? It is one class. It is still it is there. See, one class. See how many methods? Almost 300-400 methods are there in the one class. Three, 400 methods are there. Like this again. Java P, Java.util. Time.local time. See, time. Java P, Java.time.local date time. See, so many are there. One class, some hundreds of methods are there. It is not possible to learn Java library. It is not possible to learn. Okay, Java library complete. It is not possible to learn. That much vast library is there. Okay. Here, just 5-6 methods I'll give. Without knowledge, later you can call other. It's about date class. Java P, Java dot local date. This is, I'll copy to a file. Construct, no constructor. We don't have constructor here. Methods. Now, method name is now. Very regular usage methods I'll give. Year plus years plus months plus weeks plus days. Minus years, minus months, minus weeks, minus days. Very regular usage. So forward direction plus backward direction minus. Now here again and again package name is java.time, java.time. That is I'll remove. Now right is all. No. First one, static method. Remaining all instance methods. First one, static method. Remaining all non-static methods. Is it over? Now, for calling these methods, compulsory local date class object or object reference required. But here, no constructor, no parameter constructor not there, default constructor not there. That means default constructor implicitly provided. With that, if we call, where it has to start. That is the reason this method you have to call always. Today onwards, it will start. Plus months, plus years, plus days. Suppose plus days, 100 you will write. But from where? Today. That's what this method you have to call. Now if you call, today's date comes. After that, plus days 100. After 100 days, which date comes, that will come. So compulsory first you have to call this method. If we call now, today's date comes with the date plus days 100. Then after 100 days comes. Here toString method is there. No need to display format. Automatically comes. See. You observe. What you have to write? Give me answer. Direct question. What is the return type? Local date. LD equal to local date dot now. Okay. So now is a class method. With the class name I'm calling. Return type also local date. Okay. Local date class in which package? Import java dot time dot star. Okay. Now, if I print system dot out dot println ld, toString method called today's date printed. Compilation, execution. See 2023 July 19. Now, after 100 days, which date comes? I want to print. What we are write? Return type local date ld2 ld dot plus days 100. System dot out dot println ld2 after 100 days. So after 100 days, 2023 October 27. Okay. So this is after 100 days date. This is today's date. Now after also, before also, all possible because methods are plus is there, minus is there. Minus methods if you use back, plus methods if you use forward direction. Okay. Now like this you can call other methods. Note example. So today's date after 100 days date. So three classes are there. Local date, local time, local date time. Three classes. Local date only for date. Local time only for time. local date time for both date and time class. So today's date printed, after 100 days date also printed. Over. So now method is instance method or class method. That's what I called with class name. Return type is local date. Plus days is instance method or class method. That's what after getting this reference with that we called. Again return type local date. Year 2 string, year 2 string called. Okay. Is it clear? This is about date class concept. That is only date local time. That is only local date time. Okay. This is the first feature. Second one, default methods in interface. Default methods in interface. You already studied what is an interface? Collection of public static final variables and public abstract methods. But the definition totally changed in Java 8. We can write concrete methods also. Okay. That is only default method. This feature allows to write concrete methods, concrete instance methods, in an interface by using default keyword. This feature allows to write concrete instance methods by using default keyword. This feature allows to write concrete instance methods in an interface by using default keyword. Is it out? This feature allows to write concrete instance methods in interface, default keyword. Okay. Now, concrete method we can write that purpose. You observe. Is it out? Say here interface test. Here void show. Is it abstract method or concrete method? Abstract method. Is it valid abstract or invalid abstract? Valid or invalid? Valid. But where is abstract keyword? Implicitly present. Okay. Now I am writing like this. Now, is it abstract method or concrete method? What is concrete method? But if I write, error comes because here by default abstract keyword comes. By default abstract keyword comes. Then what it shows, abstract method cannot have body. Okay. If I compile, see. Compilation. So interface abstract methods cannot have body. So, but here where is abstract? Here implicitly abstract. Then what JVM understands? It is abstract method. But abstract method, we should not write body. So it is an abstract method. We should not write body. Like that, it will understand. That is the reason one keyword, if you attach, it will understand it is concrete method only. It is new feature. Okay. If you write this keyword, but actually that keyword purpose is different. That keyword in switch case will write no. Switch case 1, case 2, yesterday was in. Last default will write. That purpose, that keyword. But that keyword used here. Okay. Instead of introducing new keyword, they given default only. So now it is allowed. So if you want to write concrete method in interface, then what you have to write? Default. Then only it is valid. That is the reason this method is called default method. So actually, default method is not a concept. Default keyword, if you are writing, no, that is the reason we are calling like a default method. Okay. So if I don't write default keyword, by default, abstract keyword comes. Abstract method cannot have body. That error comes. Now I want to write concrete method in interface. Then compulsory you have to write default keyword. Then it will understand. Now it is instance method or class method. Instance method. How many ways to access? What are those? Now can we create object? No. The writing concrete method introduced, but creating object to interface not introduced. Then how to call? Implements. What you have to write? Test. Next. How to call? What you have to write? Test t equal to new demo. Next. T dot show. Valid. Okay. Object created to subclass here. Okay. Object created to demo class. Reference created to interface. That method I am calling show. See. Compilation. Execution. See. Show method. Valid no? So if you want to write concrete instance method, if you want to write concrete instance method in interface, then you must prefix default keyword. Then only valid. But writing concrete instance method given in interface new feature, but creating object still not possible. So then what you have to do? Demo, implements, test. Then object created for a subclass, reference created to super interface with that show method called like that given. Okay. Write example. See what purpose this feature introduced. I'll explain. Right, this one. Is it on? Now, what purpose this feature introduced? See, you already studied one is class, one more abstract class, one more interface, one more abstract interface. Now, is it concrete class or abstract class? What is it? Concrete class. This one concrete interface or abstract interface? Abstract interface. This one, that means third and fourth, there is no difference. Third and fourth, there is no difference. If you write, okay, class, abstract class, and interface. Even if you write abstract interface also, both are same. If you write abstract interface, both are same. There is no difference. Okay. Now here, if you want to write concrete method as well as abstract method, if you want to write concrete method, abstract method, which one you'll use? Abstract class. Okay. But now Java 8 interface also possible. In future, what they'll do, this concept they are planning to remove. Then what will be there? Class, interface. That's it. One class, one interface. That's it. Class, no concrete keyword. Interface, no abstract keyword. By default, abstract. That is by default concrete. Like that. That is their proposal. Future, what will happen? We have to wait and see. Their intention is that one. They are planning to remove abstract class concept. Then what will be there? Creating class keyword. Creating interface keyword. Creating enumeration, enum keyword, like that, 3. And record, one more is there. Record, like that only. So class, abstract class, that is, they'll remove. Only class. Abstract class will not be there in future. In future, I am saying, what will be happen also, we have to wait and see. Because they may cancel. If any issues comes, what they'll do, they'll cancel. What they'll do, they'll introduce feature one by one. Later, if any issue comes, they'll cancel also. They'll remove also. That will be happen. That is again, it may take years. 1-2 years also it will take. To add, to remove these all, it will be happen. Okay. So future, what will happen? We have to wait and see. Present abstract class also working, it is there. In future, it may or may not. Okay. Now, that purpose, this concept introduced. Now, next. What is next? Static methods in interface. Note on. Static methods in interface. This feature allows to write concrete class method in interface. This feature allows to write concrete class methods in interface. This feature allows to write concrete class methods in interface. This feature allows to write concrete class methods in interface. So, concrete instance method we can write. Concrete class method also we can write. Here, normal. Whatever you studied concrete class method, like that only. So, what we'll do here, just we'll write static. Now, this is a class method only. Now, your implementation not required. If you want to call, how to call? Test.show. That's it. It is valid, no? Test.show. It is valid. Now, it is class method. You can call with class name. Interface also dot class file generated. So test.show file save. So concrete instance method possible, concrete class method possible. Write this one. Example. In Java 9, private method also introduced in interface. So class name dot show. It is valid. Is it over? These all very simple. Now you have to listen with more concentration. Okay. Remaining all you have to listen with more concentration. Year onwards, somewhat complicated. Fourth one, fifth one, sixth one, seventh one. These four. You have to listen with more concentration. Again, these two very simple. Again, this is you have to concentrate. This is simple. These four concepts and this concept. Most important, little difficult to understand. Okay, listen with more concentration. Now, functional interfaces. Note on heading. Functional interfaces. Functional interfaces. See, you studied already interface. What is interface? It is a collection of public static final variables and public abstract methods. That is you studied. One more interface you studied, marker interface, tag interface, or empty interface. What is that? Interface which does not contain any member, no members, no variable, no method, empty, open brace, close brace, that's it. That is called marker interface or tag interface or empty interface. There is no variable, there is no method, nothing is there. Open brace, close brace. That is you studied. But one more concept, functional interface. Note an interface that contains only one abstract method is called as functional interface. An interface that contains only one abstract method is called as functional interface. An interface that contains only one abstract method is called as functional interface. It is one more concept. Okay. Only one abstract method is there. That is called functional interface. But here, not only abstract method, other things it can have. Abstract method one. So, functional interface can have default methods. Functional interface can have default methods and static methods. Functional interface can have default methods and static methods. Functional interface can have default methods and static methods. Default methods also you can write. Static methods also you can write. But abstract method, one. Functional interface can have variables also. Variables means only public static final. Because already you studied interface supports only public static final variables. Otherwise, you write interface, functional interface can have public static final variables also. Now, you observe. What I'll do, you observe. Here, void show. Can I call it is functional interface? Can I call it a functional interface? Yes. Can I call it is 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 functional interface? Can I call? No. Why? Only one abstract method required. Now, it is not a functional interface. Okay. But if I compile, what will happen? It will compile successfully. Okay. It will compile successfully. Actually, I want to write functional interface. By mistake, one more method also written. But it is functional interface or other interface, how it will understand? It will compile. It will compile. No, but I required only functional interface. No, it is not a functional interface. I want to write only functional interface, but it is not a functional interface. But what system will do? It will understand normal interface. That's what it will compile successfully. It will run. If you want to confirm whether it is functional interface or not, annotation. You can inform to compiler, no? This one. With this, you can inform to compiler. If you inform to compiler, compiler will check whether it is really functional interface or not. That purpose annotation. Okay, write this one next. Add functional interface annotation. It ensures that functional interface cannot have more than one abstract method. It ensures that functional interface cannot have more than one abstract method. See, just if you attach this one, compiler will take care. What we are saying to compiler, it is functional interface. Then compiler will check whether it is really functional interface or not. Not a functional interface, error comes. So instead of checking by you, you can inform to compiler. Compiler will take care. So just attach at functional interface. If I compile, error comes. What I am saying to compiler, test is a functional interface. What compiler will say, it is not a functional interface. Okay. So unexpected at functional interface annotation. Test is not a functional interface. Multiple non-overriding abstract methods found in interface test. I am saying to compiler, it is a functional interface. What compiler is saying, it is not a functional interface. Okay, like that. So just we can inform the compiler will take care. So like this, Spring Boot, so many annotations released. With that maximum, you can give to server only. Server will take care. Programmer point of view, burden reduced. This type. Now, no need to check now. Just attach this one. If it is compiled successfully, it is functional. It is not compiled, not a functional interface. That's it. Suppose I'll remove this. You observe. Compiled. It is a functional interface. That's it. Okay. Because now 4 methods are there, 5 methods are there. Okay. While developing project, 100 methods also will be there in one interface. At that time, no need to check 100 method body is there or not. Just attach this line, compile. Compile means there is only one abstract method. No need to see each and every line. That purpose. Okay. Here, I inform to compiler, it is a functional interface. It is functional interface. That's what successfully compiled. Okay. Now what I'll do, you observe. Another interface. Sample. Extends test. Interface. Can I insert in another interface? Yes. Which keyword? No. Void print. Okay. Void. Show 2. Okay. Show 1. Here show 2. Now, here it is also I'm writing functional interface. Is it functional interface or not? Now give me answer. Sample interface. Sample interface is a functional interface or not? Yes or no? Think yourself and give answer. Now, my question is, sample interface is functional interface or not? How many people answer yes? 1, 2, only 2 members. Online students. Hmm, 19 members, 20 members. Okay. Not working. Okay. How many people answer it is not a functional interface? Online students. No. Online response is like that. Online response, first class to last class, same position. Because whether they are listening or not listening, also they won't respond. That will happen. Leave it online. Okay. See, why it is not a functional interface? Why? This is concrete method or abstract method? Actually, it is error. Error. Okay. Suppose if I write like this, it is valid. Now is it a functional interface or not a functional interface? Is it functional interface or not? Extends keyword I given. Extends keyword I given. This method also inherited here. Then how many methods will be here? 2 methods. That's what it is not a functional interface. That method inherited here also. Here overriding, not overridden. That's what? Not possible. It is not a functional interface. Compilation. See, error. Where you are getting sample. Okay. So if you remove this method, yes, it is valid. Okay. So if you write like this, now you may think there is a one method. Okay. This is the reason this annotation is better. No, even you may get confused also. That will not get confusion. No? Compiler will not get confused. So compiler will check super interface also, sub interface also, all everything it will check. So level 1, level 2, level 3, multi-level inheritance also will be there. At the time, no need to open super class, super interface, no need to check. Attach, compiled successfully. It is functional interface. Not compiled, not a functional interface. That is the reason annotations better. But useful annotation in core Java only 2. Override, functional interface. Advanced Java, 3-4 annotations are there. Web listener, at web servlet, at web annotation, web filter, advanced Java. Later, Spring Boot, many are there. Hundreds of annotations are there. Hundreds. Okay. Now, this is at functional interface annotation. Now, example node. Example. Why this interface is lambda purpose? I'll explain. I'll give notes. Lambda expression, if you want to write, compulsory functional interface only required. In the above example, test is a functional interface. Because it contains only one abstract method. That is show. Sample is not a functional interface. Because it contains two abstract methods. Show and show2. So it is a functional interface. It is not a functional interface. Sample is not a functional interface because it contains two abstract methods, show and show2. That is denoted. That is the reason it is not functional interface. But test is functional interface. That's what, while compiling, we got the error. Sample is not a functional interface. Is it over? See. Next. These features, like otherwise, the above two features required to write lambda expressions. The above two features required to write lambda expressions. So these two what purpose is? Lambda purpose only. Now lambda expressions. Lambda expressions. This feature allows to write anonymous methods, anonymous method in anonymous class. This feature allows to write anonymous method in anonymous class. This feature allows to write anonymous method in anonymous class. Anonymous method. A method which has no name is called as anonymous method. A method which has no name is called as an anonymous method. Anonymous class you studied, no? Okay. That is confusion concept. But here one more confusion introduced. Okay. Confusion, anonymous class is confusion, but here anonymous method also introduced. But with this, we can reduce the number of lines. Okay. By using this feature, we can reduce the number of lines in coding. Or we can say concise. We can concise the code. By using this feature, we can reduce the number of lines in coding. 10 lines program, just in one line we can write. 10 lines program, just in one line we can write this feature. That type. It is required even while learning frameworks also. In advanced Java not required, but a frameworks time required. While learning framework, this feature required. Is it over? First anonymous method, anonymous class you study now. I'll remove these all. Demo, class demo, public static void main, string args. If you want to write anonymous class, what we are write? Give me answer. Test t equal to new test braces. What did I write? Public void show. Okay. Some message system.out.println welcome. Next, t dot show. Now, here, what will be happen here? One class created. Is there any class keyword? No. Is there any class name? No. That class inherits test interface. Is there any implements keyword? No. So one class created, that class implements test interface. That's what method overridden. That class object created. That class object, not test object. That class object created. That object referred by T. With the T show method called. Okay. This is anonymous class. It is not lambda. Anonymous class. This is already studied. Okay. Now, first, here any doubt is there? Here any doubt is there? That is not possible to understand. If any doubts are there here in this program. Here, see once again, if you write like this, okay, otherwise this program separate, write it one program. Then I'll give lambda. Write this one. Program to demonstrate anonymous class. Because long back you studied. Program to demonstrate anonymous class. It is not lambda, anonymous class only, previous concept only. Now, here what will be happen? Just you observe. If you write like this, one class created. There is no class name. That class implements test. Here method overridden. System dot out dot println something welcome. Here test t equal to new anonymous class object created with that show method called. This is understanding purpose I given like this. So you assume this code equivalent to this code. You assume. Then you will understand subject. If you write like this, one class created. There is no class keyword. There is no class name. That class implements test. Implements keyword also not there. Then overridden method. That this class object created. That object referred by T. With that T show method called. So anonymous class object created. Okay. It is not test object. Test is subclass object. But where is subclass? Which is subclass? Anonymous class is subclass. Okay. If you want, you can write this one also for understanding. Is it over? Now, if you write like this, one class created, there is no class keyword, there is no class name. That class implements test interface. There is no implements keyword also. Test interface method overridden. That is normal overriding. That class object created. That object referred by T with the T show method called. Is it clear? In this program, any doubt is there? In this program, any doubt is there? Now, you observe lambda expression, how it will be. Now, here, this is not required. Just one arrow. One arrow. This is not required. This is not required. Method name also not there. This brace not required. This is lambda. You observe. File, save. Compilation, execution. You observe. One line. In that line, class created, that class implemented test interface, that method overridden, that method object created. These all done. Anonymous class is there, anonymous method is there, anonymous object is there. All are present in one line. Like this. Okay. This is only one example. If you see, you will not understand. I have to explain. Tomorrow total class, this one only. Then you will understand. Okay. This is no need to write. Tomorrow you can write. Tomorrow I'll give. Okay. Tomorrow we'll see continuation.